Great day everyone and welcome back to General Physics. Today's lesson is all about distance and displacement. The objective of today's lesson is differentiate between distance and displacement, perform adding vectors in one-dimensional motion, and also calculate and solve problem involving distance and displacement. Good day class, welcome back to our lesson. The topic that we're going to discuss today is all about distance and displacement in a straight line. We all know that distance is a scalar quantity which described as total path covered. When we say displacement, it is a vector quantity which required magnitude with direction. We further discuss displacement as the nearest distance between the original or starting position to its final position. So that is the nearest distance from the original position. To further discuss that, we're going to use the YouTube video from the Easy Engineering YouTube video, and thanks to them. So to discuss distance and displacement, we're going to use their animation. For example, we have here Sarah. Sarah asked by Miss Minchin to go to the sari-sari store. The distance from the sari-sari store and Sarah's house is 100 meters. Along the way, there is also an internet shop in between the sari-sari store and the Sarah's house. Miss Minchin asked Sarah to buy things or stuff from the sari-sari store. The distance that she walked is 100 meters. Then afterwards, she moved back to their house. Question is, what is the distance of Sarah? For those my student, please choose the correct answer. Okay, the total distance is 100 meter plus 50 meters if Sarah is stopped by at the computer shop owned by Miss Amelia. And then after that, she again moved another 50 meters from the computer house, another 50 meters. The total distance is 200 meters. We define distance as distance is the only representative of a magnitude of a path traveled in meters, the SI unit. It is only quantity without direction because distance is a scalar quantity. On the other hand, let us discuss what is displacement. Mentioned a while ago that displacement is a vector quantity which requires magnitude with direction. It is also the shortest distance from the original position. Again, let us use the illustration made by Easy Engineering YouTube TV. Let us have the displacement. If displacement, Sarah moved to the store and stopped by the internet shop. Therefore, the displacement is 50 meters because from point Sarah's house to the internet shop is 50 meters. Now, to further discuss that idea, let us have a sample problem which is almost the same with that but different values and also applying the adding vectors idea. Okay, this is your house. Your mother asked you to buy some goods from the grocery. And along the way, there is store A or sari-sari store. And we're going to note your house. The distance from your house to the store A or sari-sari store is 25 meters. On the other hand, the distance from store A to store B is 10 meters. And now, to name it as x sub 1 and x sub 2, we're going to represent the x as the horizontal component. So, x sub 1 and x sub 2. To get the distance, the total distance, x sub 1, summation of d sub x is equal to x sub 1 plus x sub 2. To complete the sample problem, we're going to need a question first. The question is, what is the total distance if you walk from the store back to, or grocery store back to your house. From your house to store B back to your house, what is your total distance? To solve for that, we're going to represent the second distance as prime in order for it to indicate that that is the second situation or scenario. So x sub 1 plus x sub 2 plus x prime sub 2 plus x prime sub 1. And that is simply 25 meters plus x sub 2 is 10 meters plus x prime sub 2 10 meters plus x prime sub 1 25 meters. The total distance is 70 meters. That is the final answer if the question is distance only. But then, if it is, or if we're going to change the question to what is the total displacement, we denote total displacement as summation of d sub r. It is also known as a resultant vector. Okay? Normally, tinatawag din natin yung resultant vector or v sub r, to denote that that is a vector quantity and also a shortest distance. Applying the same problem, that is simply the total displacement, because you go back to the original position, the total displacement is 0. Please take note that when you say displacement or resultant vector, that is the nearest distance from the original or starting position. Applying the idea of adding vectors, magiging the prime sub 2 and sub 1 will be negative. And using your calculator, that is simply negative 35 minus positive 35 minus negative 35 will be 0. Same scenario. Okay, for question letter B, what is the displacement and the distance if you walk from your house to store A and B and store B and back to store store A, and back to store A. So, from your house to store B, back to store A. So, the total distance is summation of dx is equal to x sub 1 plus x sub 2 plus x prime sub 2. That is simply 25 plus 10 meters plus 10 meters is what? It is simply 45 meters. That's what you can see on the string. Hanggang it is up to store A only. 45 meters. And again, this is a distance, so no need for the direction. On the other hand, summation of resultant vector or displacement is equal to x sub 1 plus x sub 2. They're on the same direction. That's why you're going to add minus x prime sub 2. We denote the negative sign because it is backward. Okay? So, we're going to denote that as 25 plus 10 meters plus negative 10 meters. So, if you're going to see that mathematical approach, the answer is simply 25 meter. But please take note that it is a resultant or displacement. It must be a vector. It's a vector quantity, magnitude with direction. So, it is what? Towards east. How do I say, or how do we know if it is north, south, east, west? It is from the perspective from the original position or starting position, in which we all know that there is a north, south, east, and west. And again, store A is still on the side of east direction from the perspective of the original position. So therefore, we can simply say that it is along east. And if we are going to go back to your Cartesian coordinate plane idea, North is positive, south is negative, east is positive, and west denote as the negative position. So, upward, positive, ang kanyang, the sign is positive, downward is negative sign, eastward is positive sign, and westward is negative in sign, applying the adding vectors idea. So again, that is a sample problem using one-dimensional motion.
Next meeting, we're going to focus our lesson in two-dimensional motion, applying the idea of distance and displacement, and then afterwards, we're going to focus on speed, velocity, and acceleration. So please do some readings about Pythagorean theorem and trigonometric function in order for you to cope up with our lesson.